The digestive system is a long tube that extends throughout the body, starting at the mouth, leaving at the anus. The inside of that digestive tube is really the outside world. Anything that's inside your digestive tract, from your mouth through your anus, is part of the outside world, not part of your internal environment. That area, the pH of that, the electrolyte composition, the water volume of the internal environment there need to be carefully regulated. And those will change the way we digest food, and they also will be affected by the kind of foods we eat. So food material that enters the digestive tube is broken down consecutively into their building blocks, first into small pieces, then into a kind of mush, finally down to their individual monomers or small molecules of the things that make them up, like sugars, amino acids, nucleotides, fatty acids, and glycerol, which is part of the fat system. The building blocks, those individual monomers, are small dimers, in some cases trimers, are absorbed across the walls of the intestinal tube, and once they absorb, they are available for us to use to create the molecules we need in the body and to provide the source of energy for the things that we do in the body, depending on what kind of molecule they are. So that digestive process is the mechanical and chemical breakdown of foods into the forms that can be absorbed by the cells. Begins with mechanical digestion, starting right out in the mouth when you take a piece of food and break it into smaller pieces of food while you're chewing. That mechanical breakdown doesn't alter it chemically, but very quickly, even in the mouth, we begin to get some chemical digestion as food particles are broken down into smaller and smaller chemicals. The digestive system itself is the organs of the digestive system that carry out both the mechanical and chemical digestion. And then in addition to just digestion, we also need to have ingestion. You can't break it down if you don't eat it. Propulsion, you have to move that material through the digestive system. Absorption, if you break it down but don't get it across the cell walls into the body, it will never be in the internal environment. And then the whole process is going to bring in things that we cannot digest, don't need to digest, and we will get rid of that material in the process of defecation. So in total, our digestive system is going to consist of that alimentary canal and a number of accessory organs, most of which are associated closely with that alimentary canal, that assist in these processes: ingestion, digestion, propulsion, absorption, and defecation. So our alimentary canal consists of those organs that may originate from that tube, from the mouth to the anus. That is the food passageway. And some of the accessory organs we'll look at are the organs that have secretions into the alimentary canal. Food doesn't go to these accessory organs, but their secretions are important in breaking down that food. And salivary glands, liver, gallbladder, pancreas will be some of the major ones we will look at. The alimentary canal is a muscular tube. It's about 8 meters long. It goes through the thoracic and the abdominal cavities. It is the layers of that tube. There are 4 of them, from innermost to outermost, are mucosa, submucosa, muscularis, and serosa. So the innermost one, the one in contact with stuff in the outside world, is the mucous membrane. Just below that, there are submucosa that nourishes the cells and transported the absorbed food particles or chemicals into the bloodstream. The muscularis is a muscle tissue. It helps with moving the tube and mixing the food within the tube throughout. And then the serosa is the outermost layer, which produces the serous fluid that eliminates friction. So the walls of the submucosa in the intestine have the 4, so this is a section from the intestine, have the 4 walls of the alimentary canal: mucosa, submucosa, muscularis, and serosa. And we get two different kinds of movements within the tube that we need to be aware of. There is a mixing movement, which we call segmentation in many cases. So you may have heard of peristalsis before, where you squeeze one end of a tube, in this case the tube being the digestive tract, and move things forward by leaving the other end open. Well, if we squeeze in different places, we can mix on top of that segmentation. So we make this segment and mix materials between this side and this side, and then the next time that moves down a little bit on each end, and we get some more mixing. So that mixing is the result of segmentation, and movement of materials in only one direction forward from the mouth toward the anus is peristalsis. There are branches of the sympathetic and parasympathetic nervous system, the autonomic nervous system, that extensively innervate the alimentary canal. There are the submucosal plexus, which controls secretions, the myenteric plexus, which is going to control gastric motility. Think of secretions coming from the mucosa, muscle being the my. The autonomic control of digestive activity. In general, parasympathetic impulses are going to increase activities of digestive. That would be secretion and motility. Whereas the sympathetic impulse is going to inhibit those digestive actions, the secretion and motility. If you're in a point where your sympathetic nervous system is activated, you're in that fight or flight reflex. You don't need to digest your food at that time. You're going to use what you have. Save that energy for getting away. If you're resting, relaxing, go ahead and use your digestive system. Build up your reserves for when you need them. All right, I'm going to stop there for section 1.